Good morning, James. You're up early. Don't know if you missed anything here by staying in bed, but anyway, I've been out for dinner and just got home, really. Thought I'll get everything sort of a bit organised and maybe make all this sort of work. It's a warm day here. I haven't got anything really planned, to be honest, as far as actual projects. James is on Down Under time here about 7:30 p.m. Mark, g'day. Hey, Peter. I'm just actually looking at updates to give you some sort of an idea. I'm going to share this. Sort of a bit of an idea. Like I said, I've been out for dinner. I'm home. I haven't done very much. Put a chalk message on the door and posted it online. That's kind of about it. Went and organised the electricity, stuff like that. Went next level trying to learn CAD. How's that going for you, James? You touch base and actually see how we're going. Anyway, just clicked on the link, improvements to ONSHAPE. The 30th of January, so it's the end of last month. Sheet metal loft is huge, and this is great. This is a big thing, and it's pretty awesome. We might have a play with this in a blank document and see if we can make that work. 42-inch monitor for blind self, and 42-inch monitor is absolutely the answer. We might have a bit of a play with lofting sheet metal. Surface deviation with the deviation analysis tool. That's full paid, as is reflection analysis. Some graphics preferences. Touch import for a touch screen. Is your new screen a touch screen, James? Numbered lists in notes. ONSHAPE for government. Render studio improvements is huge. At some point, I'd like to get to the point that I actually afford a full membership for a little while, and then or a full subscription, and try mess with some of these things, rendering, etc., etc., etc. Someone says, blinded by sheet metal offer, failed to see touch import on devices like a Surface tablet. That's exactly right. But absolutely lofted sheet metal is a big one. So where we can get a mean. So that's a big one that's been asked for a long time. We'll have a look at that. Might have a bit of a mess. What else is happening? Anyway. Let's go back to ONSHAPE. Here we are. Now, I've been messing, as you know, with the donation box pretty heavy. I'm going to do some more of that. I've got some ideas. I don't know whether I'm going to get into that tonight or not. We'll have a look. Some of these projects were getting finished, which is great. Steve's Marshall Big Ends, those, they're on the bench there out the door. It's very good. This part here for Phil's Portable really needs some work, so we need to do something about that. Williams Lane engine is sort of starting to come together. That's something that we're going to be working on a bit more in the future. This low angle jack plane, we're going to see a bit more of that too. I'm not sure about the Bolton number 12 beam engine on the Muncaster vertical. I will get in and do some more on them at some point. It hasn't happened. And projects for 1919 keep going. Mark's rod guides are finished and delivered. I think they come up pretty nice. So I can't wait to see them machined and in place. It'd be really good. The donation box. Let's just find an untitled. Rather than start another one, we'll find an untitled document. And all this was a little oval piece to template to put an oval on the wall. If we have a look. It's that shape because that's as big as I can print, and I just 3D printed it and lined it up and draw the 4 quarters of the oval. And I've got a template. So that's something I do fairly regularly. But let's create a part studio. On this top, we're going to make a shape. A sketch on here. Let's do something a bit fancy. We'll have a look at this sheet metal loft. Let's try with a spline. So we've got a shape like that. And we're going to, I think the easiest way probably, if we finalise that sketch, the easiest way is probably put a plane, offset plane to this one that we've just drawn on. We'll make this 100 mil. We'll offset it down rather than up. How's that? We've got another plane there like that, see? If we do a sketch on this plane, and then we go press N for normal, we can do something similar. Let's make it something fun. Seven sides. Let's try out the sheet metal loft and see if we can loft this up. If we click and finalize that, we've got 2 sketches, one here and one here, all different shapes. Let's have a play with that. We're going to use this one here, which is loft, new solid, this one and this one. And what we've got is a lofted design like this. So that's how you would make a... All that's done is put a pattern between one and the other and filled it in. Now, if we go and make a sheet metal model, let's try this out. Parts and surfaces to convert. Faces to exclude. Edges and cylinders to bend. See if it will actually do this or what's involved in actually making it work. It doesn't like the fancy shape. That's fair enough. Let's move back here and change sketch 1. We'll do something a bit simpler. We'll start with something like this, eh? I'll try that. We'll delete that. We've got the 2 there. We can loft that again. Right, something a bit more simple. Let's try this. Now we make a sheet metal model. Parts to convert. Faces to exclude is that one. And that one. Edges to bend. Only planar, cylindrical, conical, or extruded faces can be converted to sheet metal. Why is that having trouble with that? Interesting. Yeah, we're going to go simpler again. Let's see if we can make this work. Otherwise, we might have to look it up. N for normal. Let's see if it does it this way. See how complicated it will get it. I might have to do some research. Let's see if it'll loft between there and there. Struggling there. Delete that. Loft. Now let's try and see what it does. Interesting. If we're advertising this, there must be a better way to do this. Let's have a look. Ah, there we go. So we've got that sorted. Interesting. Let's delete that. We're trying to do that. All too complicated. Let's see what we can do. Now, over here on this menu is a drop down. It says sheet metal loft. Look at that. If we select that, profile 1, profile 2. Profile 1. And there we go. Look at that. It's a fairly ugly sort of loft there, but it seems to work. If we have a look here at the sheet metal tab here, it gives us our flat view. So that does work. How cool is that? I know. Now we can come back here and sketch 1. Let's see how complicated we can go with it. Now we know how to do it. Sometimes you just got to experiment till you find it. Let's try that. Yeah, it's going to let us do that. So that's pretty cool. Let's make a wheelbarrow tray. Let's do it. Thickness 1.6. We'll try that. And there's our flat pattern. So let's use this for something practical. And delete some of this stuff. So looking at this, right, we're going to, how big's a wheelbarrow? sketch on here, on the top plane there. We draw a line around there and then mirror it quickly across this line here. And then put let's put a 3-point arc across here. Like so. And if we trim this one out of here, and we put a radius on the top corner here. Like so, and here. And probably here. And here. Now this plane is probably in the wrong spot, so we're going to edit that. Now, let's try this. If we move that about 20 degrees. What sort of I'm in that sort of mood tonight. Don't know how productive we're actually going to be. Let's put a new plane in here. We don't want to offset it. We want to that's not the right one. Let's start with offset. Something like that. Another one there. I think what we need to do actually, this is how we're going to do it. We go Control Z to get rid of that. A new sketch on this plane. Go N for normal so it comes around. Press that and Q for a construction line. We'll put that on there. We've got a line sticking down there. Now, if we put a plane on that, we'll make that work. So a plane here. Line angle. So on this line. That's how we do it. Close that. We'll finish this sketch 2, edit that, which is on this side plane. We're going to put this on an angle like this, something like this. I'm going to click that, and we're going to click the construction line. We're going to change this somehow. We're probably going to grab that and move that up. Move that up, something like that, so it looks about right. And then we're going to put a plane on there. Plane on that line. Let's go line angle. Excellent. Now, if we put a sketch on here, on this plane, we press N for normal. And we put a let's put a line, something like this, a box, something like this. And then mirror it. Oh, anyone's particularly passionate about all this stuff, but I am. We go to the mirror line, and then we mirror this one, this one, this one. We're going to put a radius on that. I think that's too much, but we'll click all 4 corners first. And we're going to call this 20. I reckon it's probably a good start. Move that for some reason, 20. Click that, and then we've got 2 here, something like this. Sketch 2, we can move a bit. Something like that. Now we're starting to look. Now let's try this. Sheet metal loft. Profile 1, profile 2. I can remember doing maths for these sort of drawings too. There's a collision in the model, which is there. Let's fix that. Did not generate properly. Sheet metal model cannot be built. Anyway, let's try again with sketch 3. I'm really a bit invested in this now. We'll edit that. Let's change this to a smaller radius. I think that could be some of the problem. 10. Move this out here. Move this in here. We'll go on the top so it's nicely balanced. That looks pretty good. Let's try again. So where's the problem there? The problem appears to be here. And why that's so. Let's change that. Let's fix that, I think. Caudal tolerance. 5 millimeters. Click that mode, got it. So, a bit limited, but that looks like it might work. If we cut that piece out and folded it up, you might end up with a wheelbarrow that looks something like that. Don't know if it's a particularly nice looking wheelbarrow. See if we can put an edge or a rolled edge or something on here. This is just a purely messing around sort of a job. Just for the fun of it. See if it can actually be done. Rolled edge. I'm struggling a bit with that. I'll flip it to the inside. I might have done that. So that's giving us a rolled edge. It's ugly. It's not a particularly nice wheelbarrow, and that's not really how wheelbarrows that shape are made. But it looks like it probably works. We could put some tabs on it and have something we could cut out and make a fairly usable wheelbarrow shape. In reality, wheelbarrows are more this shape. So I'm going to start a new part studio here and start again, I think. If we want to make a wheelbarrow like we've got here at the Shenandoah Steam Shed, we sketch on the top here. something that sort of shape and size. I haven't scaled this or anything. If we put another, probably do this just the same as we did before. If we go to the left side or the right side, might go to the right side. Put a line there, press Q so it's a construction line. Don't want it on that plane, we want it on the right plane. And then the Q for construction line. Oh, come on, that's where we've gone wrong. We'll start another sketch. Sketch on that plane. And then we've got all this down. Let's put a plane on that angle. And we get another sketch on that plane. Something like that. Sketch 1 can be modified a bit. Might do something a bit more fancy than that if we go out. Make the top that shape, eh? Only one thing wrong. Have to modify sketch 2 again. Try that. So if we do this again, there's a collision in the sheet metal model apparently. I don't know. Interesting. Something easier like a bent funnel, Peter says. Maybe. Okay, if we flip it the other way, we don't have a problem. Don't know why that is. Anyway. It looks a bit chunky with those big corners, but it's only fairly small. If we put some measurements on sketch 3, we call this 350. Right, measurements on sketch 1. Call it 400. On sketch 2, we edit that and we put a measurement on this one, dimension on there, make it 220. Bit ugly, but we've got a wheelbarrow back. It's a lot ugly actually if we have a look. If we have a look at our sheet metal model, there's the model for it. Now, interestingly, it hasn't shown the bottom. How do we make it so that we fold the bottom up, include the bottom of the wheelbarrow? Didn't work. So I haven't played with this as much as I could have, and this is all just a very fresh look at this. Now, I would think, if we look at this sheet metal loft, there must be a function. You would think that there would be a function. What's this connections? That doesn't work. Let's close that. All right, I'm sure there's a way we can do that. What we could do is put what we already did, put a hem on there. Come on, show us what we're doing here. So angle 270, hem alignment. New place, corner type close is a rolled hem. Nice teardrop shaped hem. So let's go rolled hem in a radius 5 millimeters. Let's go 5 mil. It's a big roll. Let's call it 3. So let's put a roll edge on it. That's no worries. I think we can put some tabs on here at least. Let's put a flange on here. So. I'm just guessing here the angle. That's not quite right, but if we go back here to sketch 3 and edit that. And we put a dimension on here. Sketch 3 is the wrong sketch. That's why we're having trouble with that. Let's try sketch 2. No, go the other way. There we go. And wait for it. You could make an extra part for it. There you go. So there's the base. Probably want to put a tab on that, do we? We've got to draw tab profiles on there to do that. That's a lot of messing around. Anyway, we know that works, so that's kind of useful. Could be very cool. Something we could actually use. What would be more useful? Use less tin, perhaps, if this sheet metal flange actually worked off this gap here. But we'll have a look at that. Anyway, that's something we've had to play with. There's only one way to find out about stuff is to get in and experiment with it. It's a really good sort of a thing to do. find out how it works. You can't. I mean, what's the worst you can do is muck up. It's delete and start again. We've done that. I think we can put a flange on that. What have we done? And put a partial flange on there. What we've got is the wrong. It's the wrong. There we go. We fixed that. We can do a thing here called interesting. So that puts a flange on there. So we can spot weld that along the front, and probably if we put one the same along each side, then we'd have a wheelbarrow or something. Anyway, very cool. That's a feature that needs some messing around with, but it might actually work. Now, let's run an idea past people here and see what they think. We'll get back onto this donation box because this is quite a project. What we've got, slowly coming together. Right. Well, we've got something like this. It looks nothing like this, actually, in reality. But what I would like to do, right, if we move this, turn that off, eh? Why have I got this in here? Something's not right. But anyway, what I'd like to do is put a false floor in here. Something like Let's get rid of that. What I'd like to do is put a false that distance off the floor, if anyone can see that cursor. If we use the dimension tool, we go between there and there. It's 290, roughly. Again, between that line there and that line there. It's not right. That line there, that line there. $280 by 290, something like that. So if we draw, let's do this. We'll put new part studio. We'll call this one false floor. I'll call it flooring. On top here, if we draw a box, sketch this and draw this out pretty quick. $290 by 290, something like that. I don't think that's quite right. And if we extrude that out 3 mil thick, let's edit appearance, make it sort of timber coloured, something like that. It's not timber coloured, but it'll do. If we go back here to the main assembly and insert that, flooring. See, what I want to do is put a false floor in there like that. Something like that. Right? On this side, there's going to be pavers or cobblestones or something. We can work that out. But we're going to put wooden flooring joists under here. This might be a fraction high. Let's go a fraction lower. But just for the purposes of it. Something like that with wooden timbers underneath. So you can see in there. Now, the lathe and forge and everything else goes up on top. That's easy. But what I would like to have is another little animation in under here. And I've been giving this some thought. Right? I don't know about CAD drawing this, but here's some thoughts. If we had 3 turn drums, right? Let's just do this. Where's flooring? Here we go. We'll make a sketch on here, on the edge there. Wrong one. We'll change this to a corner rectangle. $7 by 12, something like that. And we do a linear array for that. And we make them $80 apart. And we put 4 in. Finalize that. Then we can use our transform tool. Drag this one. Drag that back this way a bit. Something like that. And that doesn't work. So let's do it again. This is not in any way meant to be instructional, guys. I'm just here for the messing around, and I appreciate you being here too. If we transform, it's not the right one. Linear pattern, that one. Would we say 80? Something like that. Looks about right. And 4 of them. That's done that. if we extrude them the other way, that'll probably do. Right, we end up with that. Now, we'll have another look here at the main assembly. And that's sort of what we had in mind, something like that. Right? These will probably go quite a lot of the distance through. This actually sticks out the front of it, but it's not going to matter anything much. Probably it's not the only thing that sticks out the front if we have a look. Yeah, not well designed, but it sort of works. Now, my thoughts are, if we look at this from the front, right, for one, we've got to get some light in there, which is a bit of a problem. But if we had 3 wheels in here, right, 1, 2, 3, something like this. Now, because we're going to make this a actual feature or part, we're going to might as well get organized and make a folder here that says flooring. I'm going to call that flooring. We can just drag and drop that into the flooring folder. We can open that and it's there. We can create a part studio. We can rename that and call it snake body. If we have a look at the front here and sketch on that, and we put a mirror line up through the center here. Something like that. And then another line here from there out there, and we'll make these say, if we made this 35 mil radius, we've got someone to center point arc from there. Radius is, let's call that 5.5 mil, something like that. We draw a circle, make something sort of this shape. You'll see when it comes together. I'm a bit sort of scratchy tonight. Sorry, guys. Move it out there. We use the extend tool or the X tool. We stretch that around and make that match on there like that. And then we want to use the trim tool, which is M. Trim that. And then a line down here like this. This is very rough, but if we revolve this on that axis of that line, right, if we paint this, add appearance to this face here, nice green, something like that, right? And made wheels like that. We'll put axle in the middle. On the top, we'll put a put a 4mm axle or a hole, or we might extrude that and just make an axle for the purposes of this. We'll go symmetrical so it's both ways through and call it 25mm, and I call it 20mm. Doesn't really work. So let's do this way. 7, and we'll put a second end position on there, and we'll call that 8, something like that. How's that all? 10, 11, something like that. Right, so we've got a wheel with a disc in it. Now, bear with me. If I put this, or we make it, let's make an assembly here by way of getting complicated. We'll call this one a flooring assembly. And we'll insert in this the flooring and do it this way. This is what I've got in mind. I don't know if this is going to work. But this is the thoughts for a snake, right? We'll put this behind here. And then we insert another one. Bear with me. And another one. We look at the bottom here and we line all these up so that this one here goes here somewhere, and this one here goes here somewhere. Right, and then we do the whole like so. Now, for a start, this is very basic. But if we put pulleys on these, right, with a belt around them, so they all turned. I don't know whether they want pulleys or gears. I don't know which way they want to turn without experimenting with it. But you would see the pattern on the snake move that way, and then that way in a coil, and then that way in a coil, wouldn't you? And you think that there was something moving under there. Does that make any sense? Right? Now, we could build under here somewhere. Let's move these back. Back a bit further anyway. I don't know how far back. Right. It still looks the same. Without matter where you move. This one here wants to go. So you can't actually see the coil, I think, something like that. Right. Now, we can make here a snake's head that ducks in and out on some sort of a cam or a, right. And we can make another wheel, something like this. So if we make another part studio, we call that rat. And we sketch on this top plane again and make a circle like something like this. And we extrude that. We'll make it, what, 0.6 millimeters thick, something like that. And we edit the appearance. So we make it sort of that color. And we can fade this back so it's transparent. Right? And then if we make it, go back here to the flooring and insert that part. find it's nowhere near big enough. Somehow, we go back here to this and alter that sketch. Just put a measurement on that. That's easy. Come back to the flooring. What we would have here, if you made a recess in the piece that we've already got in the floor for this circle, we could probably run a little rat around the outside so it runs around the outside and disappears through these flooring here, you see? Disappears out here somewhere. And if we block this one off, then we'll put this round the back so our little rat that's on this disc that was spinning or turned was round the back out of sight. When you actuated the mechanism, we can make it so this does one complete turn and runs past, and have a snake's head here that clicks around and looks at it and follows it past while all this is moving under here. Are we following? Does that sound complicated? Is that doable? Is that something that would work? There we go. That's where I'm at with that. Are you following? The two things, or a couple of things, I guess, that one thing anyway, we'll start with, that I would have problems with this movement and mechanism, I think, is lighting, getting actual light in there. I don't really want to put battery lights or anything like that so that you can see things. I think that's a bit overkill and complicated and something we don't really want to deal with, and a bit of technology I don't like. All right, so that wouldn't work. If we could have hole in the back and a mirror, something like that, would be really good. If we could put a little mirror here in the corner and a hole down the back, a little mirror here in the corner, like so forth, across here, and a hole down the back so that the light shines in, and then that lights up across there. That might be really good. This, of course, needs to be bigger diameter than these wheels to work, so the mouse can actually go past. Now, unless there's a different sort of mechanism without the disc, just having him rush past. Guy at work who I talked to about this sort of crazy things, an artist, engineer slash tradesperson, run this past him, and he said, well, why not make a track and have a little belt or a chain and have the rat attached to a chain and 3 sprockets, and then, or a belt and 3 sprockets, and then he would follow any path and he'd be out of the way, and you wouldn't have. See, the other problem is that this here, you've got this gap in the middle that this relies on the pivot. So all this metal, all this plastic, or whatever you want to put in the middle here that spins, the operation for the lathe and everything else has got to come through it. So that means it makes it very difficult to make it spin. That's not going to work. So my thought process at this point is probably, instead of this, to have a pulley here and a pulley here and probably a pulley here or something like that, or a tooth pulley, and a rubber belt around them. Getting that out of sight is a bit more difficult. But if you did that and attached a little polymer clay rat to it, then it improves it on several levels. One is that it takes a route that looks good across the front. So instead of coming out here and going back, it just goes straight across the front, which is great, or on a bit of an angle back. All right, that works. The second thing is that you've got a certain number of turns here on the pulley to make this rat travel from wherever it is here and do a complete circle back to where it is. A belted track probably sort of works. It's a bit boring. So we can work that into the mechanism if we had like a wind-up spring and a ratchet, or a wind-up spring and a pole, or a detent, so that what happens is that you wind the handle and wind the handle and wind the handle, and the spring winds up, and then something trips it, and the rat races past and does a turn, and the other movement does the 2 or 3 turns to make it all work. And then once the rat's out of sight, you keep winding the handle, it picks up a detent and moves the snake back to where it was when the rat or the mouse is actually gone. So that's what I'm messing with inside my head. This is the sort of thing that goes on inside my head when I'm not doing anything or when I'm at work. So just in case you're wondering, there's thought processes here. What I would like to do if I did this, and it's not quite as simple as it looks, is to put the belt down out of sight in the, so if we'll call that an assembly, and we may call that main assembly, and we get this, and we delete that. And then if we insert our assemblies, assembly 1 or whatever you want to call it, flooring assembly we want to insert. All right, something like that. Sort of like that. We put a mirror here in this corner and either a light or another mirror to catch the sunlight so that we actually get some light in here. So a little mirror here diagonally across the corner so that it shines light out across here. And another one at the back so that it picks up some of the light down here and amplifies it and shines it in, maybe something like that. Now, this belt needs to be down inside this base here. So whether you route a track in here, make a template and route out a track and route out the mounting holes and mount the pulleys in here and make the shafts come up through the floor here in places so that they're hidden, and that's something you could probably do. Or if you listen carefully, you can probably hear the fuses blowing in my brain. Do we straighten all this up a bit? I've been trying to explain this to people for a while, and this is probably the best way I can think of to actually do it. Is through CAD. So that would give us a pretty convincing snake. This one here doesn't need to be this big, like it doesn't have to follow out here like this. probably. And if we had a head sticking around here, I think that would actually work. A couple of little bits of mirror. I honestly think that that might work. If you painted a texture on these or a pattern on these for a snake, like a carpet snake, so that I think the mechanism is, or the actuating mechanism is probably quite simple. Quite simple to make it work effectively. And I quite like simple mechanisms to make things do cool stuff. You would have to carve a head. That's probably the most, a snake's head is the most daunting thing. So probably you just need a piece of wood with a snake's head crawling across the ground. If you made the snake's head move from here, sort of across here, where my cursor is, if you made it crawl across here, while all this was moving, after the rat had disappeared out, he'd come out here and disappeared into there. Interpretive dance is probably really good. Therapy. And whether you had that on another wheel or another balance so that it turned at the same rate as the rest, or whether you just had something that, like on a lever with a rack, so that a gear would move that, I don't know. You would have to put some of these wheels and bits and pieces in place and then start messing around with the mechanism so that it works. I don't think it'd be all that complicated though. So that's where I'm at. It's 9 o'clock already. You've listened to me waffle for an hour and a half and probably for an hour about this. But that's what's going in my head. That might be what's going to happen. The actual fabrication of this thing is probably a bit more complicated. If I could call in a favour and get one of the wood turners I know to actually make some snake rings, it'd be really good. Maybe I should just go down to pokies for an afternoon every once a week instead of doing this sort of crazy stuff. I think we put a pattern on them, and if we put one behind the other so it never got as much light as their front two, and we could reflect some actual light inside there. And this little hole here, up this corner, this little piece here, we could cover that up so that the mouse disappears in there, and that would hide some of the mystery. I'm going to probably just make some cobblestones for this area, whether I do them with a silicon mold and some polymer clay, or whether I actually find a piece of tin and push some piece of tin plate or whatever and push some holes into it, like a piece of a cake tin or something, and mold some patterns into it and use that and paint it, or whether I actually cut some wooden cobblestones or flags or pavers or whatever. Don't know yet, but that's what's going to go there. And then this boiler thing here. Black's not a very good colour for this. But give you some idea what that looks like. Am I going to factor in away for maintenance? Yes, I believe so. This top comes off, and I guess this will just screw on. So you should be able to remove this top. It's not glued in place, this sheet here, and all this is attached to that sheet. So we should be able to just unscrew this top, right? Turn it upside down, unscrew this out of here, and we've got all the bits. So that's not even the slightest problem. It's a very good idea. Thing we've got to be a bit careful with is that when you look at this line, this from this angle, there's a gap here. So I think we need to close them up a bit more than that. If we go back here to, or let's, oops, what happened there? It's like Minecraft. Yeah, it's more fun than Minecraft because it's actually in real bits. If we turn that off, then we would have there was some overlap, so that when you looked at it from this angle or this angle, you could see the three rings, but you can't actually see through them. There will probably be an angle where you won't be able to see through them, but if there's overlap enough, you won't. Maybe. So that's something to think about. And I think probably a lever around here with a snake's head on it and some sort of a rack system. But I'm going to ditch this wheel, I think, that for a rat. I don't think that's the answer. I think probably I'm going to put a pulley here somewhere where the cursor is. So you can't see that, but there's a cursor there in the middle, and back this way where the cursor is, and probably 4 spots, something like that. And they might not be exactly 4 spots, but if we could keep the belt or something down pretty low, then maybe you could make, what would be ideal is a track with a belt in it, rather than wheels, because having wheels means that or pulleys means that it's got to, whatever you attach to it's got to work itself around the pulley without the pulley having some way to come off, without the belt having somewhere to come off the pulley. So I think if we made I'm thinking some sort of a track. I don't know what sort of style, but with reasonably radius corners, and then we could put either a rubber belt or we could put a chain or something flexible in it, and then on the top surface we could actually connect something. I guess if you use a train that was quite wide, there would be enough room on the top surface to connect a little rat or a mouse or something. Like a scale electric track, something like that, like a groove, yes. If we put 4 sprockets and a chain, like a miniature motorbike chain around it, that would be very, very durable. And it would track very nicely. And we could just put 4 sprockets, 4 little 8-2 sprockets or something on 10-2 sprockets on axles on the corners. And then the chain, you could probably put a long pin in and put a mouse or a rat on that so that it just sits up enough to run along. Anyway, thinking out loud, this project's spiraling. We know that. Don't judge me for that. But this might be very, very cool. If anyone has thoughts about that, yeah, like sort of a planetary gear sort of a thing. Like that, yes. A proper planetary gear with a circle that goes around would be very nice, but I don't know if that's doable. That's a little bit more complicated. we could recess a aluminium disc or something in there and then run it around the edge of that. Like make a piece to sit over that and use that as a track. Yes, an endless spring. If you can get endless springs, I need some endless springs, one in particular to drive the lathe, or two. Very difficult to get. Anyway, that's where I'm at, and that's what crazy stuff's going around in my head this week. I think this would be a very cool feature. It's something else to sort of to notice or to look at, or a secondary feature that's not as transparent as it could be and tells a bit of a story. And is there, it brings people back for the second time when they don't notice it or when someone points it out. And that's really nice. So I think it's doable. Honestly, I think probably I need to glue up some flooring and some joists and have that piece looking somewhere near. And I had some timber there that William Mackey gave me that's 13 by 2 or 13 by 3. Stephen Small Engines, g'day. And that would make nice flooring, but it's fiddly and it's difficult to get right and flat and it's not going to be stable. So probably my answer to the flooring is to get a bit of 2mm ply, decent quality 2mm plywood, put some scoring in it and sand it up. Put a coat of varnish on it, something like that. Next week when we re-enter the black hole load is Emma's mind. Yeah, I'm sorry, guys. So get a piece of plywood sitting there because that gives us a nice stable floor for the little lathe and for the forge, which have both got to go in here. And probably there are other things that need to go in the corner here, but they would be the two main things. That gives us a good stable flooring. And then I would probably make I sort of feel like an aluminium plate on the top and the bottom recessed into the flooring or screwed onto the flooring or part of the flooring, or I don't know. To keep the wheels positioned in the same place, and then you could put roller bearings or ball races or something in them, like cheap Chinese ball races, and all that would spin with minimum effort, and it would take very little to drive it then, and it'd keep balance and it wouldn't touch anywhere. That's probably the best way to do that, I think. It might be better to have two sheets of plywood on the top, if we can do that without getting too thick. And then we could cut the recess in one for the aluminium frame to hold everything in place, and we could just sit the other one on as a cover. So if we could find some 1.6 or 1mm plywood and put a piece of 1.6mm aluminium under it, rather than put another piece of plywood, and fasten everything to that. And in the bottom piece, we could just make a piece and recess it down, give it a coat of black paint. No one would ever know it was there. So that's my thought. We'll probably have another look at this tomorrow night. Stephen Small Engines, what we're looking at here is our donation box project. It's downstairs and I'm upstairs, but what we're trying to do here in a nutshell is to work out a way of making a coiled snake move under the floor of a room in miniature and chase a rat or a mouse across the room, or slither across the room behind a mouse that's running pretty quick. And then when the mouse disappears, go back to where it was. So this is an automaton mechanism that I'm trying to thresh out because I've got nothing else to do. So that's how it is. There's no other projects to do really. So this is what I'm doing. But I might go to bed. Thanks, guys. I've got a big day tomorrow, I think. There's stuff happening at work. I've got stuff to do. I'll be live tomorrow night, but it won't be this sort of stream. We won't be looking at a CAD program for an hour. It'll be more, I could do this. It'd be more having a look at some model steam engine stuff we've done and stuff like that. So tomorrow is probably more interest to other people, but this is, I really wanted to model this up and give some sort of an idea of how this worked. Because even to myself, I really don't have a lot of. So even from this angle, if you can see the two wheels, they all sort of work together nicely. So I think that would work very well. That's further on, to be honest. I've got thoughts about things like that, and it might be a little further down the track, but this is sort of base part. So while we're doing this, it started with a discussion with William Mackey about flooring and laying flooring down on the actual plywood, and this is what we ended up with. So this is where we come to. So if I could get this mechanism moving so that when you crank the handle, this actually works, then the rest is all pretty straightforward. But bear in mind that coming up through this has actually got to be it's got to be a drive for a lathe and some cam levers for at least a couple of puppets. So yeah. So making it all work and fit in there is a bit tricky. So probably the open track thing is probably the best because it's not in the way of anything, only where it travels. And if we worked out the position of, say, the lathe operator at least, and probably the other guy and the bellows levers and things like that. Yeah. Mark, I might go on Discord for a bit if you can be bothered. Will be on Discord for a bit. I'm about to call this because I've really run out of things to say. But thanks for listening. Probably an asylum might be a really good place to ring up about in the morning if you've got some free time, because this is really getting a bit complicated. Anyway, that's what we're doing. So automaton donation box for the club. It's going to be quite a project. Like, it really is quite a project, but it's coming together and we're starting to get a lot of little bits and get some paint. Belt drive from overhead line shaft for it's a treadle lathe, so it isn't really belt drive. It'll just have a hidden away little belt down to the camshaft that actuates the operator, and the pedal will operate his leg. So that's that one out of the way. And then his arms and his shoulders will operate. I think I can get them operating off 2 levers, probably 1 lever. But I think it's going to take 2 levers to make that operate. So that's pretty straightforward. The other guy should operate pretty nicely off 2 levers. I think the forge or the blacksmith. The forge operator, the blacksmith, he's going to operate nicely off 2 levers as well. Or 2 cams. I think I've worked that out. I've got, as we go, I'd like to get this floor in and some of these bits in place next, and then start to seriously think about getting the lathe operator in place then on top of this. Bit of work in it, and I sort of tend to over-engineer things. Probably some bent-up coat hanger wire and some holes in the plywood would last forever. But I am trying to future-proof it a bit so that it actually works and works with minimum interruptions or problems. So it's a bit of work. Anyway, I'll be in about 10, 15 minutes. I won't be too far away. Serve a spare room machine shop if anyone wants to. A crazy bunch, but we'll chat in there for a bit. But I'm going to go up to the kitchen and grab another cup of tea, because this one's excessively empty, and shut the shed. So I won't be too far away. But we'll chat soon, guys. I'm out. Thanks for watching. Appreciate it.